Good day, fellow learners. Our sister is back. Today, my fellow learners, we are going to do oxidation numbers. Firstly, I'm going to define the term oxidation. Oxidation. It is so simple. You just need to write the loss of electron. Loss of electrons. Then, let me define as well reduction. Another term that you'll come across. The reduction is just the gain of electrons. Gain of electron. The substance that loses electron, we say it is oxidized. Oxidized. Oxidation goes in hand with oxidized. Then the substance that gains electron, we say it is reduced. Reduced goes in hand with reduction. You see? Then now, what I'm going to do, I'm going to consider an atom. Let's say if I have an atom X, which is neutral, by the way, X, then I remove only one electron from this one. I remove only one electron from this one. Then what do you think the charge will be? At first it was neutral. Then I only remove one electron. Then it will become positive. Then it will become plus x plus then let me just take this negative to the right hand side, because normally we write it like this. You see, bear this in mind. I have plus one charge with this plus next to X and E with one negative charge. Then my final answer, if I were to calculate this, I'm going to get 0, which is true. You see on my left hand side, X is 0. It simply implies that it is a neutral atom. Same if I add plus 1 with minus 1 of my electron, I'm going to get 0. It is balanced. Then now, this situation, especially this one, we say it is oxidation. Oxidation. When your electrons, they are on the right hand side, we say it is oxidation. Then now let us consider another situation. This one, let's say I have X. Let's say I have, let me write it here. Let's say I have X, an atom. Now I gain what? Electrons, plus one electron. You see, I gain an electron. My atom is neutral. Then look what will happen. My atom is neutral, which is 0 plus this one. Let me open bracket for one electron. Let us calculate. 0 plus in bracket minus 1. You are going to get minus 1. Same, which is going to be X minus. It has gained what now? 1 electron. We say such situation, it is reduction. When your electrons, they are on the left hand side, we say such, it is reduction. X is reduced. Here X is oxidized. You see? Then now we are going to move to the oxidation numbers. If I have a pure substance, pure substance, let's say pure substance Ca. How to find the oxidation number of a pure substance? It is so simple. Firstly, you consider the whole element. In this case, the whole element. It has nothing there. No charge, no nothing. It is neutral. Then you are going to equate to 0. I only have one of Ca. I only have one of this. Then you write 1 Ca. Then let us divide by 1 both sides. Then you are going to get Ca, which is equals to 0. You see? It is so simple. It is so simple, this one. Now let us consider the diatomic molecules. Diatomic molecules such as C2O2. First, you consider everything, especially there on top. I only have none. This is neutral atom, neutral. Then I have none. You write 0. How many O do I have? 2. I have 2 O. Then let us divide both sides by 2. You get O, which is equals to 0. You see? Your oxygen there is equals to 0. Then let me take another situation of Cl. For an example, Cl2. You consider the whole. There is nothing there on top. Then you equate to 0. I only have 2 of Cl. 2 of Cl. 2 of Cl. You see this small number 2. Then you divide by 2 both sides. You get your Cl as 0. So simple. Now I'm going to consider ions. As for ions, let me take chloride, Cl minus. Let us consider the whole. I only have -1 there on top. You equate to -1. But now I have only 1 Cl. You write, sorry, it's minus. You write 1 Cl. Then you divide both sides by 1. By 1, your Cl is going to be -1. See? Let's say if they give you this one, peroxide, 2 minus. How are you going to solve this one? Don't be confused. You apply the same technique. That my overall charge, it's -2. There on top is -2. I only have 2 O's. 2 O's. Then let us divide both sides by 2. Then we are going to get our OS -1. You apply the same principle throughout. Now we are going to consider compounds. Compounds. Let's say if they give us MgCl2 and they say to us we have to determine the oxidation number of Mg. They want us to find the oxidation number of, let's say, of Mg. Then how are we going to solve this one? Don't be confused, ne? As for this one, you just need to use your periodic table. Then on your periodic table, especially the group 1 element, you mark on top group 1. Let me see, group 1 on top you must write +1, group 2 +2, then group 13 right +3, then group, let me say, group 17 right -1, group 16 you write -2, then group 15 you must write minus 3, sorry, minus 2 minus 3. Then after writing this one, those will represent what your oxidation according to their groups. Now they want us to find the oxidation number of Mg. First thing that you must do when you come across this situation is to consider first your overall. Is 0 there? I have nothing. Not these two. The overall there on top. I have nothing. Then you are going to say I have 1 mg plus 2 Cl, which is equals to 0. You see? Then from here, you are then going to take your periodic table and try to figure out where is Cl situated. Go to your periodic table there, group 17, and we said group 17, the oxidation number of that element is going to be -1. Then where you see Cl, put -1, then it's going to be 1 mg plus 2, you open bracket, minus 1, you equate to 0. Then you solve this, and this is going to be minus 2 equate to 0, 1 mg. Then you take 2 to the right hand side, it's going to be plus 2. Then we get 1 mg. Let us divide by 1 both sides. We get mg plus 2. Then the oxidation number of mg is going to be plus 2 for compound. See? Then now let us consider the polyatomic ion. Polyatomic ions. The example that I'm going to use is let me use sulfate 4 2 minus. Then you come across this. Then they want you to find the oxidation number of S. How are you going to use this one? Same principle, same principle. You consider the overall. Oh, the overall I have -2. Then S, I only have 1S plus 4 O's. See? 4 O's. Let us go to our periodic table. They want us to find S. Let us go to our periodic table and look for O. Oxygen in this one. Oh, we see that, okay. O is group 16. Group 16 is -2. Where you see O, you put -2. It's going to be plus 1S plus 4, you open bracket, then write -2. Equals to -2. Then let us solve for this one. You are going to get -8. Yeah, -8 equals to -2. Then 1S. Let us take this one to the right hand side. Then we have +8 -2, which is 1S. When you solve, you are going to get +6 for S. You see? This is how we do the oxidation. Then now, what I'm going to do from here is bear in mind that if, let's say, I have let's say if I have H, let me take this compound HCl. Let's say by chance they want us to determine the let's say the oxidation number of Cl. How are we going to do the oxidation number of Cl? Firstly, you must consider the whole thing is going to be 0, obvious. I have nothing there on top. I have nothing. They want us to find the oxidation number of Cl. See the question. Then how are you going to find the oxidation number of Cl? On your periodic table, hydrogen H, you'll find H on group 1, then it's going to be +1. Firstly, you are going to consider everything, the whole oxidation number is 0. I have 1H plus 1Cl. Then the oxidation number of H is going to be on your periodic table +1 plus 1. Let me write it like this, is equals to 0. Then from here you multiply everything, you get +1 plus 1 Cl is equals to 0. You take +1 to the other side, it's going to be -1. You are left with Cl. Divide both sides by 1. Then we get Cl -1. This is the oxidation number of what? Of Cl. See, then from here, I thank you guys.